Thank you. It's a great pleasure to be here. Thanks for joining us. I'm going to talk about a few things we can do with languages on the JVM. Let me just start with saying, why do we care about doing this? Well, one of the reasons is I'm a huge fan of programming languages when it comes to ability to express. And one of the things I look for in languages is how easily can we get our work done. Now, Java has really evolved over the years, but I would say some of the languages we're going to talk about here today are really part of the reason why Java has actually evolved, because these languages have been forerunners to show us how the language can be very effective and easy for programmers to use. So I'm going to talk about a few dozen things we can do really well in these languages. Well, today, of course, we have the ability to mix and match these languages on the JVM. Especially with Graal, of course, we can also be really polyglot. So this even more is really no longer, I would say, ambitious, but really practical as well. So let's talk about a few things we can do with these languages. Let's say we want to read the content of a file. Now, I want you to just think about this. I know it's really hard to really think too much about it, but think about how you would write code in Java to read a file. Yeah, that's how it feels, isn't it? So you would have to first start by using new buffer reader, new file reader, and then remember that while the line is not equal to null, that's a smell, isn't it? And then, of course, you haven't even gotten to all those try and catch blocks. By the time you are done, you don't even remember what you started doing. Well, you don't have to work that hard, actually. For example, let's write a piece of code here in Groovy to see how we can read a content of a file. So I'm going to say new file. Let's just read the same file that we have here, Groovy, as you can see right in here. So I'm going to just print that file right there. It says sample.groovy is the file, but I want to read the content of the file. How do we really do this? Well, it turns out that Groovy actually adds quite a number of convenience methods to existing Java classes in the JDK. So as a result, I can simply say text over here, and that is Groovy code reading the file itself. So that becomes absolutely trivial and simple to do, as you can see, just about a line of code. Of course, you can write your try and catch blocks around it if you really wanted to, but you're not forced to really write it. That becomes a lot easier. Similarly, if you're writing code in Scala, for example, so let me switch over here to Scala, I can say in this case scala.io.source, and I can ask it to read a file from file, and I can specify the sample.scala right here. And of course, that gives us an iterator, but I can then take the iterator and I can say make string, and that is a piece of code that is reading the content of the file itself. Almost no effort at all to be able to read these contents, as you can see. So that gives us a focus on getting the work done rather than getting dragged into doing a lot of work. Well, how do you talk to an external process? Well, I'll share a story with you about this. About maybe 6 or 7 years ago, I had to write a program that would receive a request from a user and then launch a process on my server to do some external work. And I looked at the entire code. To be fair, it was not really a long piece of code, about 200 lines of code, that's all. But then I was curious about the 200 lines of code, and I looked at where I had spent most of the effort in the 200 lines, and I was surprised that out of the 200 lines, nearly 70 to 80 lines of code was just to talk to the external process, to start the process, to send the input, to get the output. And I thought to myself, wow, that's a high or a signal-to-noise ratio or low signal-to-noise ratio, and there's so much of code involved to just the ceremony of talking to an external process. And of course, programmers will secretly tell you it's more fun to rewrite code than reuse code. So I decided to rewrite this whole code, and when I got finished, the code to talk to external process became like 3 lines of code. Here's an example of how we can actually do this. So let's take a look at an example here in Groovy one more time. So I'm going to simply take a string I call get help, just to show that I'm calling into an external process. Hey, that's a string after all, and of course I print the string. No surprise, it simply says get help. On the other hand, once again, I can call an execute method. And in here is a string class, the java.lang.string, but appended with or added to a new method, which is the execute method. If you run this code, you will notice it's actually a process object that you get. And once again, you can get the standard output from this by calling the text, and that's of course the output of the get help coming through. And you can see that you can use these kinds of convenience methods to get the work done very easily without really spending too much time and effort. And again, the point really is you don't have to waste your time and effort to get work done. You can focus on the process. Now, this is one thing that intrigues me. Often I ask the question, why do programmers get gravitated towards languages like Python and Ruby and so on? And part of the reason is that these languages make it extremely easy to prototype. And what is prototyping and what is development in general? And to me that is, development to me is a series of light bulb moments. You're sitting and writing code, a colleague comes to you and says, hey, I'm trying to get this work done, how do I do it? And you tell your colleagues, oh, that's really easy, you could do it this way. And your colleague says, really, can you show it to me? And then you sit down and you realize the compiler wants 700 things for you to do, and you're like, never mind, you go ahead and program it yourself. It's not really that much fun because we get dragged into the ceremony of doing things. But when the languages can get it done really quickly, it becomes a lot easier for us to work with it. Let's go a little further to see one more thing. Now, when Java introduced the lambda expressions, I was very curious to say, lambdas are not new. They've been around for a very long time. What did people do when they had lambdas in other languages? And out of pure curiosity, I started looking for very old literature. I came across this one interesting book called Smalltalk Best Practices by Ken Beck. And I started reading the book out of no, real reason to use Smalltalk, but just to see how lambdas were used in Smalltalk. And I came across this one pattern. I noticed that this has been used in a lot of places, but I'm going to show you how to do that here in Java. So let's say for a minute we have a class called a resource. Now this class resource, imagine for a minute, is going to use external resources. So I'm going to write a constructor right here. And in this constructor, I'm going to simply say, we'll say created for a minute. And I have a method over here called, let's call this as op1. And of course, all that the op1 is going to do simply is to output, let's say, op1, but I'm going to simply return the current object. Well, we could write one more method right here. We'll call it op2, and all I'm going to do is simply print out op2. But let's imagine there's an external resource this particular object is using. Maybe a database connection, maybe a connection to a web service, whatever that could be. How do I really clean up those web services or external resources? Well, we know that Java has automatic garbage collection, but unfortunately automatic garbage collection is not instantaneous. And we also know that it's not going to deal with anything other than memory. So in the old Java, what we could do is we could use the finalize method. If they were to refactor finalize method, a better name would be bad idea for this method. That was really a horrible, horrible idea to implement this method in the first place. Now I'm very happy that they finally got the courage to deprecate this method in Java 9. So if you're running the code in Java 9 or beyond, you'll get a warning saying that you shouldn't be using the finalize method. But imagine I'm going to write a piece of code right here. I'm going to simply say clean up external, let's say, resource. Well, that's great. I can clean up the external resource, but how would I really use this? Well, one way to think about it is I could create the object of resource, and I could say resource, and I could call the op1, and I could also call the op2. Well, unfortunately, though, in this case, when I run the code, you will notice it did not really call the garbage collector. What's happening? Well, the reason is, of course, there's no guarantee that garbage collection will actually run. If there's a lot of memory, the garbage collector says, I don't have to really run it. Because in Java, the garbage collector is like the garbage collector in my neighborhood. Just because I put the garbage out doesn't mean anything. So how do you really deal with this? And the people who wrote Java really have a very good sense of humor. And I love this really. Because what they did was they said, here's an idea, and they gave system.gc. And when you run the code, it really does nothing. And so what is it really? There's a best way to describe this is called hope, right? Because programmers are desperately trying, maybe I can try this. So absolutely, there's nothing works in this case. This reminds me of actually a real project I got invited to work on. And the boss called me and said, hey, Venkat, come on over, review our code, and maybe in the process you can help us to figure out a problem we've been having in production for a year. I said, oh my gosh, problem for a year. And I said, what's the problem? The boss said, don't talk to me, go ask the programmers. And I asked the programmers, and nobody would tell me what the problem is. How do you really find what a problem is when nobody tells you? But then finally I found one programmer who nailed it. And he said, our application works fine most of the time. I said, this is great. Can you tell me when it doesn't work? He said, oh, of course. It doesn't work between 7:15 and 9 in the morning. I said, oh my goodness, every day. He said, no, only Monday through Friday. It works fine on the weekends. So I was like, this is very helpful. Well, then what I did was I was looking at the code and trying to find out what was happening. And to my surprise, as I started code reviewing, I found out, seriously, this is what they had done. They had requested for a database connection in the constructor, and in the finalize method, they had removed closed the connection. Well, clearly, because there was a lot of memory in the system, it never got to the finalize method. The constructor was blowing up. That was not being handled properly. This was a portal application. Now you know why it's 7:50 to 9 in the morning and why not Saturday and Sunday, because not enough people show up to work. Well, once I found this, of course, I was very curious. So what I did was I simply went to this application and I said, close. I just renamed the finalize to close. That's all I did. And then I came down to the resource and I called the close method. And I said, go ahead and try it and see if it works. One of the developers said, oh my gosh, you fixed the problem, because before you added the database connection keep increasing. Now that you added it, it stays pretty flat. But of course, the best part of that was the afternoon when the boss came back from lunch. The team was so eager to report him and said, hey, good news, Venkat helped us to solve the problem. And he said, really, what did he do? And they said, he asked us to write one line of code, and we put it and the problem is gone. And I could, hear the boss asking, what else did you do? It's like nothing else. And there was a long pause, and then I heard him ask, well, if he only added one line of code, do we still need to pay him? So the point really is that obviously this is not a good solution in this case, because there could be an exception in the code. What do you do about it? Well, clearly, of course, you need to put a try and catch around it. And of course, if you were to move this into the try block and come back and say finally over here, and within the finally block, you're going to go ahead and put this code. And of course, that would take care of cleaning up the resource, even if there was an exception. Well, that's great. But the problem really here is, even if you were to do this, now the code is verbose, and it's very easy to forget this. What if the developer forgets to call the try block? What if the developer doesn't put the final block properly? And what if this code is becoming really, really verbose? Well, good news, Java 7 introduced a feature for this. So what did Java 7 do? They introduced ARM, which stands for Automatic Resource Management. And this was a really, really interesting feature in Java 7. And so what do you do for this? You simply say implements auto-closable. And auto-closable is an interface with one method, which is the close method. Now, of course, the beauty of this particular approach is you can remove the finally block, but you can simply take this resource from here and you can simply drop it in there. Hey, isn't that beautiful? That is very concise piece of code. So you can use ARM to write this code. This way, you can use the try with resources, and you don't have to put the finally block. The code is more concise. Hey, that's awesome. Shall we go home? Well, not so fast. Let's think about this for a minute. What if I come back to this code and I write the resource like this, and I go ahead and call the resource 1 and resource 2, op1 and op2, but I forgot to call the close method. I forgot to put it in the try and catch. What's going to happen? That's the question. Well, let me guess. It's going to give us an error because the resource implement auto-closable. What do you think? No. Okay, it's at least going to give you a warning. What do you think? No. Because deep down in your heart, you know one thing. Never to trust a feature that has the word management in its name. So the point really is, of course it doesn't do anything for you, isn't it? So the chances are this is not going to take you anywhere. So when you run this code, unfortunately, you can see that didn't really do anything for you. And the result is we'll blame the programmers to say, if you only know how to write code, well, how about writing the code in a way we don't have to forget this? So how do we do this? Enters the EAM or execute around method pattern. So I'm going to say resource.close over here, and clearly it's calling that, but this is not a right code. It's also easy to forget it. What can we do? Well, here's the step number 1. Forget about auto-closable. Doesn't really help us a whole lot. Let's make the close method private. When you make the close method private, of course, it tells you you cannot call close. The programmer doesn't care less. They don't worry about it. That didn't solve your problem still. What do you do then? We'll make the constructor itself private as well. how do you really create an object if you don't have access to the constructor? Enters the pattern. So what we're going to do here is to, first of all, let's go ahead and import java.util.function.star. So this brings in the functional interface, which is the consumer interface. And what I'm going to do here is to public static, let's say, a void use method. In this case, we'll create a resource object equal to new resource. And then we'll put a try block around it. And in the finally block, we'll go ahead and say resource.close. Of course, as the author of the class, I will certainly remember to do this because I'm designing it that way. Then what I'm going to do here within the try block is to say block and go ahead and say .accept and pass the resource to it. So as you can see here, this particular use method creates the resource, passes that down to this particular accept method, and whether it comes back alive or dead, it calls the close method. Now, what in the world is the block? Well, the block is a consumer object, and of course, in this case, consumer functional interface rather, and we say the block over here, so that becomes a way for us to use the use method. How would we engage this one? You will say .use, and you get the resource object right in here, and then of course, in this case, we'll call the resource.op1, and then we will go ahead and call the op2 method right in here, and then close the resource right off the bat. So as a result, you can see how the cleanup of the object happens automatically for you. So this becomes a lot more elegant way to write it. Before you enter the block, certain initialization has taken place. You do whatever you want to do within the block of code, and when you leave, the cleanup happens for you automatically. And so that becomes the use of the execute around method pattern. Some languages call this as a loan pattern, like for example, the object is on loan to you and you're able to use it in between, and that becomes a lot easier to work with. So it's a common pattern in a lot of different languages. We can use this for implementing some policies in Java where certain pre-op has to take place and a bunch of post-op has to take place after that as well, and you can implement that really nicely, as you can see in this particular example. So with that said, let's move on a little further to the next one. I want to just mention a few things about this really quickly. Well, Scala doesn't have interfaces directly. Scala has traits, and obviously the question is, what's the purpose of traits? Well, one of the nice things about traits really is traits give us interfaces in Java in terms of the traits in Scala. But then, of course, Scala has had traits from the day one, and that begs the question, how is a trait different from an interface? Well, to begin with, a trait could have not only abstract methods, a trait can also have implementation of methods as well. And I know as an observant reader, you say, wait a second, but now Java also has default methods and interfaces, then what's the big deal? So that's a really fair question, and when I started digging into it, I realized that the difference really is not that Java doesn't have default methods now, they do, but Java still has one thing deficient compared to what you can have in Scala traits, which is really the stackability. And to me, stackability is a wonderful feature because you can take an object that implements multiple traits and you can stack them so that the calls can navigate from one trait to another. And this really becomes a true implementation of the concept of mix-ins that give you a better design idea or design capability, if you will. So in that regard, traits really are useful until, of course, Java implements stackability. I'm not sure when that will happen, but that's a really nice feature to have. So if you're not, familiar with traits, I would encourage you to take a look at traits in Scala and how you can benefit not only from traits, but also how you can stack up traits as well. I would encourage you to take a look at that one. Well, this is another feature that I'm really a big fan of. I came across this in a lot of different languages earlier, but of course Java also has that now. Let's think about what this means with an example. Let's say we have some collection of names given to us, and I'm going to say in this case arrays.asList, and let's say these are, some names I'm going to create over here and use it. So these names over here that I'm going to create, and what do I want to do? Let's say print the names of length, let's say 4, in uppercase, and then of course comma separated. So that's a very simple problem, isn't it? And it's not a rocket science, it's not nuclear research, obviously. So simple problem should have simple solution, and complex problem should have an affordable solution. How do you really write code for this? Well, okay, so we could say for string, this is coming from name, and that's come from names of course. And I can simply say if name dot equals, well, name dot length is equal to 4, and I can simply output name dot to uppercase, and then of course I could say convert it to uppercase and print it. Well, that was very easy. Oh, but wait a minute. The names have to be comma separated. We can put them in comma separation. Obviously, the intent was to have them all on the same line. So I can simply go back here and say that. And when I run this code, of course, you will get the output. Well, almost the output. But what you notice is that comma in the very end, isn't it? Anyone who has faced that problem before? Yeah, every one of us, right? And the first day you ran across that, what did you tell yourselves? You said, this is not happening to me, isn't it? Because how do you get rid of that comma? And you think for a bit and say, oh, that's easy. And then you realize, darn it, the string is immutable. And then you spend a little bit more time, and then you suddenly say, hey, how about using string builder? And then your colleague says, is it string buffer or string builder? And you can never make out of it, right? And then you're thinking about this and scratching your head. And when your colleague says, why are you struggling so hard? There's a very easy way to solve the problem. And you're really, what is it? All you have to do is simply not print the comma for the last one. How do you do that? Int I equal to 0. And you know how that is going, right? So the minute you get this, 20 minutes later, you're still working with it. In the meantime, the boss is like, are you done yet? And you want to strangle them, isn't it? Well, this is called accidental complexity. It doesn't have to be this way, unfortunately, but we get dragged into it. So what can we do to get around this? Well, here's an idea. Let's start with the output names.stream. And of course, this gives us the stream iterator. And in this case, we could say filter, given a name, we could say, give me the name dot length is equal to 4. Hey, that's great. We got all the names which are of length 4. Then what I can do here is I can say map over here to a string to uppercase, get the uppercase conversion of all the names. And then you can call a collect method at the very end of this. But to the collect method, what you can do is bring in the collectors. And I have to say that collectors is probably one of the most intriguing classes in the JDK. It's got such a wealth of functions in it. But what you can do with the collectors is simply you can call the method called joining right there, and you can just print it comma separated. Honestly, I have to say how simple this really is. The day I learned about joining, I cried that night. This is the way it should really be, isn't it? Absolutely, that it takes away all that ceremony in the code and makes life really easy. And that is exactly what you're doing here, is to simply iterate in the functional style and use the joining to really put it together, and that becomes a lot easier to work with. So we can remove the accidental complexity and the ceremony in the code by discovering functions like this. Like I said, this is available in Scala. You saw me use make string a few minutes ago. It's an equivalent of joining in Scala. You have joining in Java, join in Groovy, and similarly join string in Kotlin. So a lot of different languages provide that. Well, given that, of course, let's move a little further along. And I want to talk about something a little different here in the case of Scala, but you can do this in a lot of different languages as well. Let's say I have a compute method right in here, and the compute method is going to simply do the following. Let's say I want to simply provide over here a print line called, and all I'm going to do is return n times 2. Nothing really complex, but imagine this is a function that's going to take a lot of time and effort to execute, and you don't want to really waste time doing it. So val x equal to 4, all right. I'm going to say if x is greater than, let's say, 5, and compute of x, let's say, is greater than 7, I want to print, let's say, path 1. Otherwise, I'm going to simply say else, I'm going to simply say path 2. Well, question for you. When I run this code, will compute be called? What do you think? I'll give you a clue about it. It's yes or no. No. Absolutely won't be called. Why is that? What's the feature called? That's right, short circuiting. Wonder who did that, right? Well, John McCarthy introduced short circuiting way long ago in Lisp. And of course, every single programmer knows about short circuiting. When you look at an expression, you know to look for short circuiting. That's because mothers feed their children, telling them, when you grow up, look for short circuiting, otherwise you'll be surprised in programming. So we know about this all along. Well, that's great, right answer, it doesn't get called. On the other hand, I'm going to take this guy right here and say temp. Why? Let's go a little further. What if I really wanted to come in here and say path1 width, and I'm going to say compute of x. So obviously in this case I want to print the value of compute, but I don't want to call it twice. That won't be very efficient. So what am I going to do? I got a bright idea. I'm going to take this code and say temp over here. That way I can simply print the temp over here. And as a result, I can go in and say temp is equal to, and I can just save that away. Well, that seems like a really good optimization, so we don't run that twice. But the question to you is, will compute be called now? Yeah, unfortunately, yes. But let me ask you a different question. Should compute be called now? No. Well, you think it shouldn't be called, but you know one thing already. If you disagree with the compiler, you know who's going to win. So the point really is, in this case, unfortunately, it's going to call. Now, obviously, the question is, why is it going to call now and not before? And the answer to that question is, the compilers simply tell us, what if compute had a side effect? I know you protest, you say, wait a minute, it had a side effect a minute ago. Well, that's really called as language specification. What does language specification mean? Don't argue. That's what it means. So the languages kind of make up these rules and we have to follow that. But obviously in this case you don't want it to call, what do you do? Well, you can give a hint to Scala. You can say, hey Scala, I want you to consider this as lazy evaluation, so as a result, don't bother invoking it. So by annotating it with lazy, you're telling the compiler, if you come across this variable, wait until the first use to execute that code, and don't bother running it until that point. So obviously in here, if I change it to 14, you can see that it did the call to the call method, but without it you can see it is actually skipping it, so that can be a nice way to execute it. Similarly, in the case of, if you will, in the case of Kotlin, you can do a very similar thing as well, that Kotlin provides a way for you to defer execution. Like, for example, how? Let's say we are going to call a function called compute, and I'm going to specify this is an integer which is going to return an integer right in here. I'm going to simply say called over here. And then, of course, in this case, if I want to return the result of this, let's say n times 2. Now I define a x equal to 4. Similarly, if x is greater than 5 and compute, let's say, of x is greater than 7, like we did a minute ago, I'm going to say path 1 right in here. Otherwise, we'll go ahead and simply say this is path 2. Well, given this, of course, because of short-circuiting, you will know that it's not going to execute the compute method and bypass that. But on the other hand, if you were to use a temp like we did a minute ago, so I'm going to say temp over here and temp is equal to that, and you will notice that it is actually calling the method. But how do you bypass this? Well, Kotlin does this a little differently. In the case of Scala, lazy actually was a keyword in the language. Kotlin does this very differently. This is one of the things that excites me, is not just look at the syntax on the surface, but go a little deeper and understand what the language is actually doing. Well, Kotlin actually has a fairly interesting idea of implementing delegates or delegation. So in the case of Java, we often use inheritance. We rarely actually benefit from delegation because the language doesn't have a syntax. Well, in the case of Kotlin, they have a special syntax called the by, which allows you to delegate calls to a delegate object. Now, you can simply use delegation in general for your own code, but laziness is implemented as part of the delegation in this particular case. So what I can do is I can say val temp by lazy, and then I can just wrap this here into a lambda expression right off the bat. And as a result, when I run this code, you will notice that it is not calling the particular compute method, because it defers that and delegates to the compute only on demand. On the other hand, if I were to say this is 14, you can see that it actually goes back and calls the method. So you can use the lazy, but in this case, lazy is not a keyword. It's actually from the Kotlin standard library. But the real keyword here is the by, which is the delegation syntax to delegate calls, so you don't actually have to incur the overhead when you actually use that. So that gives you an idea about how we can benefit from this particular syntax in this particular code. Well, the next thing I want to show you here is something that has intrigued me for a long time, which is the ability to do pattern matching. Now, here's the good news. Java will have this capability in the next 3 versions of Java. As the very first version in Java 12, you actually have this switch statement has become the switch expression, so you can actually return from a switch. And this is going to improve even further in 13 and 14, and we're going to have really full-blown pattern matching in Java, a very elegant syntax. But before we, get to use that, we can look at some of the nice things about pattern matching in other languages. And namely here, I'll show you how you can do this in Kotlin. So how do we benefit from some kind of a pattern matching? Let's say process right in here. And this particular process that I'm going to use over here, I'm going to call it with a 1. Let me call this with a 14 here. Let's call process with a, let's say, a hello right in here. So if I were to call with these 3 values, maybe I want to handle this particular data based on what the type of the object is or the value. So I'm going to call the process and say input, which is any input that's going to be given to me. Now, when can be used as an expression? When can be used as a statement? I'll use it as a statement right in here. I'm going to say when input, and I can say else, and all I'm going to do is simply print whatever. So this becomes like a catch-all situation, and I can simply say, if I don't know what it is, I'm going to just print it. Well, Kotlin gives a warning saying, you have not used the input, ignore that for now, we'll worry about this later on. It will go away once we start using the input. Now what I want to do is to deal with the value 1. So I could say if the value is a 1, I could simply print 1 right in here. And as you can see, for the value 1, it printed 1, and whatever for the other 2. But where this becomes really exciting is, you can also say in, let's say 13 to 19, and then you can print out a teen, for example. So you can take this to the next level, and you can actually look for a value in a range of values as well, and that becomes a lot easier to work with. Similarly, if you really are interested in type checking, you could say is a string, and then in this case, I could say got a string, and you can see in this last call with the hello, it prints got a string. So that gives you an idea about how you can use the pattern matching syntax to elegantly write code in Kotlin. Similar syntax you can do in Java in the future as well, but something that you can get ready for very nicely. Now, having said this though, there are times when we want to do something a little bit more when it comes to programming in these languages. Let's examine this a little bit in Java. To be fair, Java will change in the future to do what I'm going to talk about now. But of course, Java doesn't do this today. But let's take a look at this real quick. Suppose you have a function called process, and I take an input which is of type, let's say, object for a minute. And this could be dealing with multiple types of object. So I call process with the 1, I call process with the hello. Well, great. What do I want to do with this process in here? Okay, don't try. So this is one thing I want to emphasize. There is one negative to writing code in multiple languages. And that is, I program in 15 different languages. What I'm telling you in so many words is, I'm not good at any one of them anymore. As you can see here, you write Kotlin syntax in Java, and Java is like speeding on you. Okay, fine, let's go ahead and change that really quickly. And then, of course, this is going to be input. All right, so what am I going to do with this particular... Okay, this is another thing. The other day I was having an argument with Java, and Java was saying, you're missing a semicolon. And I was staring at the computer saying, I'm not missing it, you see. Well, missing it means that you are just dying to see it. No, I don't want it. So the point really is, of course, you need to have the syntax proper. Okay, let's go back to this code. I want to say, if, let's say in this case, I just want to print it. Let's print the input and say what it really is. And you can see that in this case, okay, this is Java still. My mind is still not converting to Java. All right, run that again. So you can see that in this case, you're able to print it. Well, I want to say if input is an instance of a string. So if it's an instance of string, what do I want to do? I want to output right here, you got a string. Well, that's great. I'm going to tell it that you got a string of this particular type. That's awesome. But I want to say what the length of the string is. So I'm going to say over here, input.length. Would that work? No. What did I miss? You need to go to this code now and write this beautiful syntax. You have to say string like this, and you have to write code like that one. Does anyone know what this feature is called? You call it casting, I call it punishment. Because you have already asked it is the type string, and it said yes. And now it says, pay me the toll again. And this is one of the things I want to ask you. This is the question. When you program in Java, oftentimes, I often ask the question, do you work for the compiler, or does the compiler work for you? In the case of Java, often I feel like the Java compiler says, do that for me. And you're studying and working, and Java says, are you done with it? No. It says, I'll be back from lunch, see if you can get it done. And you are sitting and doing all this work. Well, the good news is, in the future, Java will not do this also, because it's insane. It is just not productive at all. So what can we do about it? Well, the good news is Java will have the feature that's available in Kotlin, which is a smart casting available in the language. So the language can be very sensible to know that you have actually paid your dues already. So in this case, I'm going to say input.length, as you can see, you got a string and it says of length, let's say of length. And you don't have to work too hard. And it says that you have a string of that particular length, as you can see right here. So when I run the code, you see it says, got a string of length 5. Make no mistake, of course, if you are outside of this block, and if you were to say input.length, the compiler will scream at you, because obviously length is not available on any, so you cannot do it over there. But since you have gone through that check already, within this branch alone, you can treat the variable as a type string. And like I mentioned, Java will be doing this eventually as well. And when Java has that feature, you can remove all that verbose casting we end up doing, and don't have to be punished so often. And we can remove a lot of that particular ceremony in the code. Well, the next thing I want to quickly show you here is about creating an XML document. So let's think about this for a minute. Let's switch over to Groovy for a second. Let's say langs is equal to, let's create a bunch of languages here just to play with. So what do I want to create? Let's say over here, Java, and we'll provide Gosling right here. Let's go ahead and say Ruby, will provide one more here. Let's say Mots, and maybe we'll just provide one more C++, and we'll throw in that particular language in there, and we'll say Strustrup. So in this case, of course, question is, if I know how to type. So let me try this again. All right. There we go. Did I say it right? Okay. C++ is always trouble, as you can know. So let's try this again. S-T-R-O-U-P. All right. Maybe. So what do I do here? I want to print the languages, the XML generation of these. How do I create an XML representation of all these things? Well, let's think about this for a minute. Anyone here who has written code to generate XML before? It's okay, you're among friends. I can see people reluctantly raising the hand. Those who raise the hand, keep your hand up if you want to go do more of that tonight. Not a single hand stays up, isn't it? Why? Because once you do it, you quickly realize the job of writing code to generate XML should be given to people in the prison. Nobody in the free world should be forced to do it, isn't it? And that's how you feel about it. So, but the good news is you don't have to work really that hard. We can use builders to write a nice Fluent DSL syntax. Let's give it a try. So I'm going to say builder is equal to groovy.xml.markupbuilder. And the fact that you can actually mix languages, you can easily reach into it really nicely. So I can say builder.languages right in here. Now, the minute I do this, look at the beauty of this particular effort in writing the code. So what can I do with this kind of code in the language? Let me see what this is doing here. No such property. Groovy is complaining. Well, let's see what's going on here. So I'm going to go ahead and say builder is equal to groovy.xml.markupbuilder. That's what I'm using here. So that should be coming from the Groovy. I'm not sure exactly why that is messing up. Let's come back to that in just a second. So I'm going to go ahead and create this over here. Something is messed up here. So this is going to bring up the groovy.xml.markupbuilder. And then once I bring up the markup builder, what I can do is that I can simply say .languages to create an XML representation of it. Imagine it's working right now. So what I can do then is, of course, I can say langs.each. So for every single language that's in there, I can start writing the code to produce the XML output. So here you can say key, value for these two, key and the value being the language and the author of the language. And then what I can do here is simply say language over here, and this would of course give me the particular language as a child element of this particular output. And once I get this, of course, I can say, in this case, we could say name is going to be the key that's provided for us. And if I really want the child element, I could say author and provide the value in it as well. And this would produce a XML output, assuming that I had the references correctly over here. And the output would look something along these lines of, simply put, it would say, for example, not nil, of course, languages. And then within that, it would have created a language at this point. And of course, in this case, the name of the language would be, for example, Java. And then, of course, the author would be displayed here for you as well. And then so on. It can produce that really nicely. So without a lot of effort, you can generate XML documents. And that makes life really easy, as you can see. So that's one example of how you can benefit from some of these ideas. Well, I want to talk about 3 more things here really quickly. One is about a tail call optimization. Well, this is something that intrigues me. And just to give a reference to this, there's a fantastic book out there, which is the book on really a book about in the first level of MIT. They use a book to teach computer programming, which is pretty intriguing. And they talk about, looking at a code in terms of processes and also in terms of procedures. And this is, of course, the structure and interpretation of computer programs. If you Google for SCIP, so SCIP, you will be able to find it. And this book, of course, talks about what is called a process, a procedure, and, of course, a difference between these two. So a procedure is the code you're going to write. A process is what runs behind the scene. So you could be writing a procedure as merely an iteration. And of course, if you write an iteration of a code, what does it really execute as a process? No surprise over there. It's going to run as a iterative process as well. Of course, we all know that writing recursion is really cool. Because when you write recursive code, it becomes very intriguing to express recursion. If you remember the joy of recursion the day you learned about it, you probably had a recursion party that night, and you had all your friends over and showed them how cool recursion is. And so you can write the code recursively, and you can run the code recursively also. But the problem with recursion, unfortunately, is it falls flat when the input size is really large, and you may end up with a Stack Overflow error. Remember the day of the recursion party you were celebrating, and that dude who always hates you came to you and said, try this input, and you tried it, and the party was over, isn't it? So what do you do about it? Well, the structure and interpretation of computer programs talk about one approach where you can write it as a recursive procedure, but the compilers can nicely rework the code into a iterative process. So as a result, you can get the best of both worlds. You can write your code as an iteration, but you can benefit from that running as a recursion and benefit from running it as an iteration as well. Let's see how we can actually do this. I'm going to take a very silly example here of a factorial. And in this case, of course, let's say n is an integer. And maybe you want to start with a big integer as well. And then what are you going to do here? You could say if n is maybe less than 2, you can simply return the value of n at this point, which is 1. And of course, big int of 1, that's what you want to return. And this is, of course, the return type is an integer. The input could be an integer, but the return is a big int. Of course, if it is not, what do? You can say return factorial of n minus 1, of course, n times n minus 1. This is a very typical recursion that we all are used to. So if you were to call this function and say factorial of, let's say, 5, you can see that it's a 120. But what if you try factorial of 5,000? Okay, don't try to memorize that. That's a value that it gave you. What if you tried maybe, let's say 50,000? Not sure why you want to do it, but it gives you a Stack Overflow right there. So what do you do about it? Well, this is where the tail call optimization really nicely comes in. So the compilers like Scala and Kotlin compilers and Clojure and so on can actually rework this really effectively for you to be able to benefit from tail call. But of course, the function has to be in the tail call position for you to do this. So how do you turn it to a tail call? Well, if you look at this really carefully, the last function you call here actually is multiplication, not the factorial. You want to rework this to be factorial as the last call you make. So what you could do here is factorial is a big int. Let's go ahead and say this is a big int. I want to actually push that to here. Let's say factorial is going to be big int. And now that you have a big integer on this equal to big int of 1, let's say, you can give a default value to it. So then you can say if the value is less than 2, I want to simply return the fact itself. Otherwise, I want to call the factorial, notice the tail call, and then I can say n minus 1 comma, and I can simply say n times the fact over here. So how do we go about using this one? So you can call it with the value of 5, if you will. Notice the value is 120. Try it with the 5,000 again. But on the other hand, try that with the 50,000, if you will. And you can see that in this case, it doesn't have a problem with it because it rewires the recursion into an iteration. But of course, if you really want to verify this is actually tail recursive, you can put a tail rec annotation on, in the case of Scala, and that's a keyword in Kotlin as well you can use, and that way you can verify that the compiler is able to see this truly as a tail recursion, and you can benefit from that. Java doesn't have a tail recursion right now, but if you're really intrigued, explore that. You can use lambdas and lazy evaluation to implement a form of tail recursion in Java as well, if that is something you want to take a look at. Well, I want to give you 2 more tips over here. And the next one I want to talk about is an extension method in Kotlin. Now, if you're used to languages like Groovy, you know you can inject method into classes. Well, in Kotlin being a statically typed language, you can actually have extension methods too. In fact, this is used a lot within the Kotlin library itself. So what can you do? Let's say for a minute I have a greet is equal to, let's say hello as a string. And I want to just print the string really quickly right here. And you can see that in this case it printed hello. But imagine you're meeting a friend after a very long time. You're not going to go to your friend and whisper hello to them. If you're like me, you'll scream hello, isn't it? So I'm going to call a shout method to express my eagerness to see my friend after a long time. How really sad there is no shout method on string. Anybody thinks there should be a shout method on string? Absolutely, I agree. So, but of course you should never take no for an answer, isn't it? So I'm going to say string.shout is a function equal to 2 uppercase, and you can write your own extension methods in the language very easily. Now, how Kotlin does this is actually by introducing static methods. It doesn't really mess with the bytecode. So this becomes a nice way for you to extend the behavior of classes to add convenience methods. I worked in an insurance business writing code, and we wanted to add methods to the date class based on our domain. So you can have domain-specific methods introduced to classes very effectively, and that can be very powerful. But before I move on to this, I'll share with you one story though. I was teaching this in a class, and there was a gentleman kind of like right in the middle of the room, and he got absolutely excited when he saw this. And his enthusiasm could not be contained. He said, whoa, wait a minute. Venkat, can you do this? He said. And then he wanted me to write 2 lowercase is equal to 2 uppercase like this. And then, of course, if I were to write this hello like this, when you run the code, you can see in here, I'm going to change it to 2 lowercase. And when you run the code this time, it prints them all in uppercase. Now, what really surprised me was not the fact that Kotlin can let you do it. What surprised me was how happy this programmer was when he found out he can do this. We had to contain him and call the cops to make sure he doesn't go home and try this. This can be really dangerous. Don't do this. Well, the last thing I want to mention here is the fluency of the language. And of course, fluency gives ways to write not only expressive code, it can be a pathway to writing beautiful DSLs as well. So just to give you one example of it, we're not putting semicolons. That's really nice already. But let's say we have a class called pizza for a minute, and I'm going to create a spread function. Well, we'll take a topping of some sort right in here, which is a string, and I'm going to simply say, just go ahead and print it out. We'll say spread, and we will say topping, and we will output the topping given to us. Okay, great. So how do I use this? I'm going to say pizza is equal to new pizza, and pizza.spread, let's say, and I'm going to spread, let's say cheese over here. And of course, I'm going to say pizza.spread, and I absolutely love olives. Let's go ahead and put some olives on it as well. When I run this code, of course, you can see in this case, this is, okay, never mind, this is Kotlin code. So when you run this code, you can see it's doing that. But of course, this is a bit noisy, isn't it? Wouldn't that be nice to remove the ceremony in this code? So I'm going to remove the dot, I'm going to remove the parenthesis, and I'm going to remove this parenthesis in the end as well. And that would be really Fluent syntax, as you can see. But unfortunately, that doesn't work. But Kotlin gives you a clue about how to make this work, something called infix it said. So I'm going to make this an infix method, and as you can see right there, it did not have a problem executing that code at this point. So when I run this code, you can see it was quite happy to accept it. So as a result, you can drop your dots and parentheses. If you have a single parameter for the function, you can write code like this and remove the ceremony. And of course, this can be a nice way to start creating Fluent syntax, which can lead to implementing internal DSLs with a really nice compile check as well, and that can be very beneficial. So I gave you 12 different tips on things you can do with these languages. I love mixing and matching languages to get work done effectively. And of course, if you're in an enterprise where you have the ability to do that, hopefully some of this are useful. If you're interested in downloading the code examples I showed you, you can point your browsers to that URL. Hope that was useful. Thank you.